All right, this is homework number 26. We're practicing U substitution. We start with indefinite and then we'll get into definite integration as well. So first problem says find the indefinite integral, check the result by differentiation. I'm not going to check the result just in interest of time for the video, so you can check that on your own. All right, so I do not need to use U sub for this. We talked about this in class. Just because you see parentheses now does not mean you have to use U sub. If the y on the outside is not 1 degree less than the y on the inside, U sub is not going to work. So instead, I'm going to distribute the radical y through. So now the integrand is 9. I'm going to make it y to the 1/2 minus y to the 1 plus 1/2 is 3/2 dy. And now I can integrate. So this is 9 times y to the, add 1 to that, 3/2 divided by 3/2 or times 2/3 minus, that's the first term, boom. And then minus, add 1 to this, you get y to the 5/2 divided by 5/2 or times 2/5 plus c. I can clean things up a little bit. 9 over 3 is 3, so 3 times 2 is 6. Y to the 3/2 minus 2y to the 5/2 over 5 plus c. Simplification is not required on free response problems, but this would most likely be something in a multiple choice, and they are not going to leave their answers unsimplified. All right. Number 39 says solve the differential equation. So part of this chapter also is just knowing like what do these directions mean. So they give you a dy dx equation. What they want you to do is solve it, meaning let's multiply the dx over to this side. We'll talk about this more when we get to chapter 6, but this is like separate. And then we're going to integrate dy to get this to y equals. So we're solving the differential equation by getting the general solution. And that means that I would need to integrate over here 4x plus 4x over the square root of 16 minus x squared dx. And so what does that look like? Remember, you can break this into two different integrals, and that's kind of what we need to do because I can integrate 4x, no problem, but this second expression needs u sub. So I like to take a moment to separate them out like this. When you separate them, make sure you write dx as a part of each integrand. All right, and so then this one is 4x squared over 2, so that's easy. This one takes some u sub, so let's do that off to the side. So u would need to equal 16 minus x squared. Du dx would be negative 2x. Solve that for du. Du divided by negative 2x should equal dx. So if I replace dx with du divided by negative 2x, the x's out here will cancel. 4 divided by negative 2 is minus 2. And now I have it set up as 1 over radical u du. Then I can integrate that. I'm also going to simplify here. That's just 2x squared minus 2 times, so this is u to the negative 1/2. So if you add 1 to that, you get u to the 1/2. Instead of dividing by 1/2, multiply by 2. There's a plus c out here. And then I'm just going to replace my u with the expression in terms of x. So 2x squared minus 2 times, or how about we just make it minus 4, times 16 minus x squared to the 1/2 plus c. All right, number 49. Find the indefinite integral. So this means integrate, and we should have a plus c as our answer. We'll use u sub as needed. So anytime the angle inside of a trig function does not have a derivative of 1, then you need u sub. So u equals 4x. Du dx equals 4. Du divided by 4 will equal dx. So I sub out dx for du divided by 4. That means that it's really 1/4 times the integral of the sine of u du. That's 1/4 times the integral of sine is negative cosine u plus c. And then that's negative 1/4 cosine of 4x plus c. For the next one, the u should be the angle x squared. Du dx is 2x. Du divided by 2x is dx. So let's sub that out. That's du divided by 2x. This x outside of the function cancels with this one, so u sub worked. So this is 1/2 times the integral of the sine of u du. That's 1/2 times negative cosine of u plus c. That's negative 1/2 times the cosine of x squared plus c. All right, for this one, again, how do you know if you've got two different trig functions and they're both to powers? Your inner function, I would go with the one that's in the denominator. Like, I don't want u to be cotangent cubed, but if I let u be cotangent and it's in the denominator, the du dx will help cancel out what's left in the numerator. So when in doubt, u should be something from the denominator. Du dx is equal to the derivative of cotangent is negative cosecant squared x. So du divided by negative cosecant squared x will equal dx. So this dx is getting replaced with du divided by negative cosecant squared x. So that cosecant squared cancels with that one. You do still have a negative integral of 1 over u to the third du. That's negative times, so this is u to the negative 3. So when you add 1, you get u to the negative 2 divided by negative 2 plus c. Let's clean things up here. So negative times negative 1/2 is positive 1/2. Let's send the u squared to the denominator. So 1/2 times either cotangent x in parentheses, or I can just write cotangent squared x plus c. But make sure you put the squared after the cotangent. If you do that, it's wrong if you write cotangent x squared. That means you're squaring the x, not the cotangent. All right, for the next section, find an equation. Find an equation for the function f that has the given derivative and whose graph passes through the given point. So we have a derivative equation, we have a point. So our goal is to find f of x. F of x is the integral of negative sine x over 2 dx. So first I start with an indefinite integral. So this is, so I need some u sub happening. So u is equal to x over 2. Du dx is equal to 1/2. Instead of saying du divided by 1/2, I'm going to say 2 du is equal to dx. So dx is 2 du. And that means that I have negative 2 integral sine of u du. That's negative 2 times the integral of sine is negative cosine. Instead of u, I'm going to say x over 2 plus c. So right now I have f of x is equal to positive 2 cosine of x over 2 plus c. Now use the points. When x is 0, f of x is 6. So 6 equals 2 times the cosine of 0 over 2, or just cosine of 0, plus c. Remember that the cosine of 0 is 1. So this is 6 equals 2 plus c, and that makes c equal to 4. So find the f of x that has this derivative and goes through this point. It's f of x equals 2 cosine of x over 2. Now I know that the plus c is actually plus 4. All right, same thing for 65. So begin by saying, well, f of x will equal the integral of 2x times 4x squared minus 10 squared dx. That's going to take some u substitution. So we're going to let u equal 4x squared minus 10. Du dx equals 8x. Du divided by 8x equals dx. So take this dx out, replace it with du divided by 8x. 2x over 8x reduces to 1/4. So now I have f of x equals 1/4 times the integral of u squared du. And that's 1/4 times u to the third, 4x squared minus 10 to the third, over 3 plus c. So right now f of x is equal to 4x squared minus 10, the quantity to the third, over 12 plus c. Now we put in the point when x is 2, f of x is 10. So 10 equals 4 times 2 squared, so 16 minus 10 to the third over 12 plus c. Be careful, you can't multiply. I see this a lot. You can't multiply the 12 over to the side because it's attached to a plus c. So we're going to have to subtract this. So let's change 10 to 120 over 12 minus 6 to the third over 12. That equals c. Now I could figure out 6 to the third and subtract, but I'm also thinking like, well, this is 6 times 6 squared. So 6 over 12 is 2. 6 squared is 36 over 2. I can probably reduce this, right? 120 over 12 is back to 10. Maybe I didn't need to make that 120 over 12. So 10 minus 18 is c. I'm getting that c is negative 8. All right, so I guess I didn't need this. I'm going to change this back to 10. All right, so anyway, what is f of x? So f of x is 4x squared minus 10, the quantity, to the third power over 12. Instead of plus c, now I know it's minus 8. All right, number 81. Evaluate the definite integral. Use a graphing utility to verify your result. Again, I'm not going to do the graphing utility part, but it's a good reminder and good practice to type this into Desmos and see if you get the decimal version of your answer. All right, now square roots are kind of weird. Normally I say, well, the thing on the inside needs to be 1 degree higher than the thing on the outside if u sub is going to work. That's if we have polynomial expressions. But go ahead and try this. Let's let u equal 1 plus radical x. Then du dx is 0, and then x to the 1/2 becomes 1/2 x to the negative 1/2. And remember, that's like saying du dx is equal to 1 over 2 radical x. So the nice thing about that is instead of saying du divided by 1 over 2 radical x, I'm going to say 2 radical x times du equals dx. So even though this extra part is in the denominator, it will cancel out because I'm multiplying by 2 radical x du. So that radical x does cancel with that one. So we have 2 times the integral of 1 over u squared du. And remember, you have choices right now. You can either keep the bounds in terms of x. This is x equals 1 to x equals 9. So you can keep them like that. Or you can change the bounds to be in terms of u. So you need to figure out what they would be then. So remember, u is equal to 1 plus radical x. So when x is 1, that's 1 plus radical 1, which is 2. When x is 9, it's 1 plus radical 9. 1 plus 3 is 4. So you could set this up as 2 times the integral from 2 to 4 of 1 over u squared du. Either case works. The reason I point out both is because if you're selecting from multiple choice answers and they're not getting you the answer, they're just getting you the setup, sometimes they will use the bounds in terms of x, and sometimes they'll use it in terms of y, or in terms of u. So you need to know which is which, or how to do both. Either way, the antiderivative of u to the negative 2 is u to the negative 1 divided by negative 1. So that doesn't shorten my work right here at all. And for this one, I do want to replace the u with its expression in terms of x and clean this up a bit. So this is really negative 1 over 1 plus radical x. On this side, same thing. I want to clean this up, but I'm going to keep things in terms of u. Okay, and then here I'm getting 2 times, if I plug in 9, I get negative 1 over 1 plus 3 minus, put in 1, negative 1 over 1 plus 1. And let's just finish the math here. Negative 1/4 plus 1/2. So negative 1/4 plus 2/4 is positive 1/4. So 2 times 1/4 is 1/2. What about the math over here? So you're just plugging in 4 and 2. So 2 times negative 1/4 minus negative 1/2. See how the math works out the same? So all you're doing basically is, instead of, when you change the u's for the bounds, for the limits of integration, when you change those to be in terms of u instead of x, you're just kind of changing the order in which you do these steps. So here I subbed in the x values back where the u was, and back here I just did that first and then worked the rest of the problem. So it really doesn't matter. I don't think that one way is easier or more challenging than the other. You just have to pay attention to what you have. All right, same thing on this one. So let's see, u is going to equal 4 plus x squared. Du dx is going to equal 2x. Du divided by 2x will equal dx. So dx is du divided by 2x. So this x cancels with this one. So I have 1/2 times the integral from 0 to 2. Again, this is leaving it with x's, of the cube root of u du. Or I can say u equals 4 plus 0 squared, 4, or u equals 4 plus 2 squared, 8. So I could also set up 1/2 times the integral from 4 to 8 of the cube root of u du. So either way, the antiderivative is the same. So this is u to the 1/3. When you add 1 to that, you get u to the 4/3 divided by 4/3, or times 3/4. And here I'm going from 0 to 2. Here it's the same thing. But this one is evaluated from 4 to 8. So in the first version, when everything is in terms of x, I need to change out the u. So also, you can factor a 3/4. If you have a constant like this, as long as there's no other addition or subtraction, you can factor the constant out and say 1/2 times 3/4, and then this will just leave me with 4 plus x squared to the 4/3 from 0 to 2. That's just because otherwise you'd have 3/4 when you plug in 2 minus 3/4 when you plug in 0, and you're going to get the same thing. Okay, so anyway, this is 3/8 on the outside. And then when I plug in 2, I get 4 plus 2 squared. So I get 8 to the 4/3 minus, when you plug in 0, you get 4 to the 4/3. Let's look back here on the blue step. Same thing, you can take out the 3/4. This is going to stay u to the 4/3. So remember, you're not changing things in terms of x. And then that is 3/8 times, we're at the same place now, 8 to the 4/3 minus 4 to the 4/3. All right, do we need to keep simplifying this? I think you should be able to. It's not required for free response, but it is expected that you know how to do this. So remember, this means the cube root of 8 raised to the 4th power. Cube root of 8 is 2. 2 to the 4th is 16. Now, 4 is not a perfect cube. You are raising it to the 4th power, though. So think about this. You have the cube root of 4 to the 4th. That means you can take a 4 out, and you're left with a 4 underneath. And because 4 is only 2 squared, when you break it down to its prime factors, there's no perfect cube that goes into it. So, like that. If you still don't see this answer, maybe they distributed the 3/8 through. So again, just be able to do that. 16 over 8 is 2, so 3 times 2 is 6. Minus 3 cube root of 4 over 8 reduces to 2. So you're not required to simplify it any further. Your math would be the same here. But you need those skills. You need to be able to do them in case you're searching for the correct multiple choice answer. Okay, next question. Find the area of the region. Use a graphing utility to verify your result. Again, I'm not going to actually verify in Desmos, but it's good practice if you want to do that. And this graph is going from 0 to 7. Okay, now this one actually is tricky. We have a trick that we need to employ here. U sub is not going to work, right? Because if I let u equal x plus 1, du is equal to dx. That doesn't cancel this out. And I can't just distribute an x through because this is a cube root. It also doesn't help me to make this like the cube root of x cubed to be able to distribute it through, because then u sub wouldn't work. So what do we do? Still start with u sub. So let's say u is equal to x plus 1. And I use this trick anytime I have the same degree out here, and like regular u sub didn't check out, didn't work. So u is equal to x plus 1. Du dx is 1, so that just means du equals dx. That's easy. So right now I have dx is du. This is cube root of u. What about this x right here? Nothing is canceling it out. Well, you're allowed to take your u equation and solve it for x. So u minus 1 would equal x if I just subtract 1 over. And I can replace the x with u minus 1. And let's see how that helps us. So the integral from 0 to 7 of u minus 1 times, let's make this u to the 1/3 so it's easier to work with. And rather than using any further substitution, I can distribute u to the 1/3. So it's the integral from 0 to 7 of u to the 1 plus 1/3 is 4/3 minus u to the 1/3 du. And I can integrate each of those terms separately. So if I do that, I get, instead of u to the 4/3, I'm going to, u to the 4/3 becomes u to the 7/3, but I'm going to go ahead and put x plus 1 back in. And then it would be times 3/7 minus u to the 1/3 becomes u to the 4/3, putting the x plus 1 back in. Instead of divided by 4/3, times 3/4, going from 7 to 0. If you plug 7 in, then both of these become 8. So 3 times 8 to the 7/3 over 7 minus 3 times 8 to the 4/3 over 4 minus, when you're putting in 0, you don't get 0. You get 3 times 1 to the 7/3 over 7. So 3 times 1, or just 3/7, minus 3 times, again, 1 to the 4/3 over 4. And maybe I would leave my answer like that if it's free response, or we should be able to simplify a bit. The cube root of 8 is 2. 2 to the 7th is 128. 2 to the 4th is 16. minus 3/7 plus 3/4. What if I still don't see my answer? Well, I see two terms that have 3/7, so it'd be 3/7 times 128 minus 1 minus 3/4 times 16 minus 1. That's 3 times 127 over 7 minus 3 times 15 over 4. And I'm sure I could get common denominators, but I'm just going to kind of stop there. What if you were keeping things in terms of u? So the alternative is, let's see, so u equals x plus 1. So if x is 0, then u starts at 1. And if x is 7, then u goes to 8. And it'd be the integral from 0 to 8 of u to the 4/3 minus u to the 1/3. I would get the same antiderivative, except I would get 3u to the 7/3 over 7 minus 3u to the 4/3 over 4. And I'd be going from, oh, sorry, not 0, from 1 to 8. And then I would get to the same place and carry on the same way. Sine x plus cosine 2x. And it looks like we're going from 0 to pi. So I've got the integral from 0 to pi of sine x plus cosine 2x dx. And remember, you can integrate separate terms. So when you separate this out, we don't need any u sub to do the integral of sine x dx. We will need a little bit of u sub to do the integral of cosine 2x dx. So this first integral is just the integral of sine is negative cosine, and you're going from 0 to pi. This one needs a little bit of u sub, so let's let u equal 2x. Let's let du dx equal 2. That means du divided by 2 equals dx. That means you have plus 1/2 integral from 0 to pi of cosine u du. I'm not going to bother with the extra u substitution. You could change it to, if u equals 2x, it could be the integral from 0 to 2 pi cosine of u du. It's not going to make a big difference either way. Now let's see, this is negative cosine of pi minus negative, so plus cosine of 0, plus 1/2. The integral of cosine is sine, and instead of u, I'm going to put my 2x back in. This is negative times negative 1 plus 1 plus 1/2 sine of 2 pi minus sine of 0. Sine of 2 pi, the y-coordinate on the unit circle at 2 pi is 0 minus sine of 0. 1/2 times 0 is 0. Positive 1 plus positive 1 is 2. All right. Evaluate the integral using properties of even and odd functions as an aid. So I could just go through and integrate from negative 2 to 2 on this one, but they want me to think about even and odd functions. So first off, what is this function? It has all even exponents, so that's a good hint. Although all odd exponents with a constant could throw things off. So this is even because if you plug in negative x into this and simplify, you get the same thing as the original equation. F of negative x equals f of x. So that means instead of having to go from negative 2 to 2, I could say I'm going to double the area from 0 to 2, or negative 2 to 0, but I'd rather work with positives, of x squared times x squared plus 1 dx. And I don't want to use u substitution on this because this is the same degree as this. But remember, you can distribute through. So 2 times the integral from 0 to 2 of x to the 4th plus x squared times dx. The integral of x to the 4th is x to the 5th over 5 plus integral of x squared is x cubed over 3 from 0 to 2. This is 2 times 32 over 5 plus 8 over 3 minus 0 plus 0. That's 64 over 5 plus 16 over 3. And we could keep going on the math, but I'm just going to stop there in interest of time. All right. Use the integral from 0 to 4 of x squared dx equals 64 over 3 to evaluate each definite integral without using the fundamental theorem of calculus. So what they mean by that is they don't want me to find the antiderivative and do all of the work by hand. They want me to use even and odd functions again. So this is the graph of x squared, which is a nice classic even function. And what they've shown me is the area from 0 to 4 is this area, whatever, is 64 over 3. And I do know that the integral from negative 4 to 0, that area, has to be the same because this is a symmetric, y-axis symmetric graph. So without doing any work, I can say the integral from negative 4 to 0 is also 64 over 3. If they want the area from negative 4 to 4, well, that's just 2 times 64 over 3, so 128 over 3. Again, no algebra required. If they make this the integral from 0 to 4 of negative x squared, I can either put the negative out in front and say, well, that's negative 64 over 3. I don't know why that's such a huge negative sign. Or I could think about the graph. Negative x squared goes down here. So, yeah, it would be a negative area, negative 64 over 3. And if we're going from negative 4 to 0 of 3 times x squared, I can put the 3 out in front so that it's 3 times 64 over 3. Or I could think about, yeah, if I triple all of these y values, that's going to triple this area overall. All right. 108. Use the symmetry of graphs of sine and cosine functions as an aid in evaluating each integral. So, all right. So first thing is to make sure that we know the sine graph and the cosine graph. Sine graph is odd. It's the one that looks like this. And then on this side, because we're going into the negatives, it looks like that, sort of. Maybe I should just, yeah, there we go. And most of these go from pi over 4 to negative pi over 4. So pi over 4, you need to know that that's at radical 2 over 2. And negative pi over 4 is at negative radical 2 over 2. So we're talking about this area. So for the first one, sine is an odd function. So yeah, if you're going from negative pi over 4 to pi over 4, that's just 0. What about the cosine function? So the cosine function is an even function because it has y-axis symmetry. Cosine is the one that looks kind of like this, and then on this side, same thing. So when you're going from pi over 4, which is also at radical 2 over 2, it's the same at negative pi over 4. So the integral from 0 to pi over 4, if I double that, I would get the whole thing. I am going to do a little bit. It doesn't tell me not to use integration at all, so I'm going to do this just to verify. Let's go 0 to pi over 4. So the antiderivative of cosine is just sine. And yeah, you're going to get radical 2 over 2 minus 0. So the integral from 0 to pi over 4 is radical 2 over 2. And because cosine is an even function, I can just double that area to get radical 2. If I'm going from negative pi over 2 to pi over 2, same thing, right? It would be sine of pi over 2 minus 0. So that would be 1 minus 0. So this would be 2 times 1, which is 2. Now, remember, you can't just multiply things together. This last one, this is half of a double angle formula, but I think I would just use u sub. I would just say, well, u could equal either sine or cosine, but it's easier if you let u equal sine. du dx can equal cosine. And then du divided by cosine can equal dx. So the cosine will cancel. So this is the integral from negative pi over 2 to pi over 2 of sine of u du. And we know that sine is symmetric, so this is going to come out to 0. Oh, and that was the last problem. All right, so this just kind of takes practice. Please come and see me if you need more practice on either indefinite or definite integration.